This is a question dealing with LeChatlier's principle, and LeChatlier's principle is essentially if you disturb a system at equilibrium, it will move to achieve a new equilibrium, and stress is on new. Something's going to be different about it that alleviates the stress that disturbed the system. Alright, so we'll see how it applies to this example. If we have a system here that's initially at equilibrium, what happens to the value of Q if we add Cl2 gas? Well, let's remind ourselves, Q has the same form as K. Meaning that you calculate it the same way. So Q is a concentration of the products raised to their coefficients over the reactants raised to their coefficients. Alright, so if we have a value of Q and we add Cl2 gas, that's going to cause the concentration of Cl2 gas to increase. So accordingly, if the denominator is getting larger, that means Q is going to get smaller. So if we were at an equilibrium, Q would no longer equal K, and we would seek a new equilibrium. So the direction the system would shift in order to achieve that equilibrium would be in a direction that increases the value of Q. So that Q would equal K again, and that would thus be our new equilibrium. Okay, in this instance, if we want to make Q larger so that it can equal K again, we're going to have to go in the forward direction from left to right. And in that process, we're going to consume some of the PCl3 and Cl2. And additional amounts of PCl5 are added. So if we revisit our statement, LeChatlier, if you disturb a system at equilibrium, it will move to achieve a new equilibrium that alleviates the stress. The stress in this situation is added Cl2 gas. The response as we've just discussed, is that it's going to move in the forward direction so that PCl3 and some of the Cl2 is consumed. Some of the stress is alleviated. Okay, we call this a shift to the right. And as a result, some of the added Cl2 gas is consumed. That is, our stress is partially alleviated.